When installing a pass and Seymour Trademaster receptacle, it is important to loop wires around the screws in a counterclockwise fashion. This instruction ensures a secure and reliable electrical connection. The direction in which you wrap the wire around the screw plays a critical role in preventing the wire from loosening over time. When tightening the screw, a clockwise rotation is typically used. If the wire is also wrapped clockwise, the tightening action tends to push the wire outwards, potentially causing it to slip from under the screw head. This can lead to a loose connection, which can cause arcing, overheating, and even electrical fires. By wrapping the wire in a counterclockwise direction, the tightening of the screw pulls the wire inwards, effectively tightening the connection and preventing it from loosening. This method creates a more secure and reliable electrical contact. The process of looping wires around screws in a counterclockwise fashion is a standard practice in electrical wiring for several reasons. Firstly, it enhances the mechanical security of the connection. When the screw is tightened, the counterclockwise loop causes the wire to be drawn more firmly against the screw head and the body of the receptacle. This creates a tighter grip, reducing the likelihood of the wire becoming loose due to vibrations, thermal expansion and contraction, or other mechanical stresses. Secondly, a counterclockwise loop improves the electrical conductivity of the connection. By ensuring that the wire is tightly pressed against the metal surfaces of the screw and the receptacle, the contact area between the wire and the receptacle is maximized. This reduces the electrical resistance at the connection point, allowing current to flow more freely and efficiently. Reduced resistance minimizes heat generation, which is crucial for preventing overheating and potential fire hazards. Thirdly, it promotes long-term reliability. A properly made connection using the counterclockwise loop method is less likely to degrade over time. The tight, secure connection prevents corrosion and oxidation from forming at the contact point, which can increase resistance and reduce conductivity. By minimizing these factors, the lifespan of the electrical connection is extended, reducing the need for maintenance and repairs. When preparing to connect wires to a receptacle, begin by stripping the insulation from the end of the wire, exposing approximately 3/4 of an inch of bare conductor. Use a wire stripper to avoid nicking or damaging the wire. Nicks can weaken the wire and create hot spots. Next, use pliers to create a loop in the wire. The loop should be sized appropriately to fit around the screw head. Ensure that the loop is closed, with no gaps between the wire ends. This will maximize the contact area with the screw and the receptacle. Position the loop around the screw so that when the screw is tightened, the loop closes further, drawing the wire inwards. This ensures a secure and reliable connection. Tighten the screw firmly, but avoid over-tightening. Over-tightening can damage the screw or the receptacle, or even strip the threads. A snug fit is sufficient to create a good electrical connection. After tightening the screw, give the wire a gentle tug to ensure that it is securely fastened. If the wire comes loose, retighten the screw or remake the connection. It is important to follow these steps carefully to ensure a safe and reliable electrical connection. When working with electrical wiring, always prioritize safety. Firstly, turn off the power to the circuit at the breaker box before beginning any work. This will prevent electrical shock. Secondly, use insulated tools to protect yourself from accidental contact with live wires. Thirdly, wear safety glasses to protect your eyes from debris. Fourthly, if you are not comfortable working with electrical wiring, consult a qualified electrician. Electricity can be dangerous if not handled properly. There are several types of receptacles available, each designed for specific applications. Standard receptacles are typically rated for 15 amps and are used for general-purpose applications. Heavy-duty receptacles are rated for 20 amps and are used for appliances that draw more power, such as refrigerators and air conditioners. Ground fault circuit interrupter, or GFCI, receptacles are designed to protect against electrical shock in wet or damp locations, such as bathrooms and kitchens. Arc fault circuit interrupter, or FSI, receptacles are designed to protect against electrical fires caused by arcing faults. When selecting a receptacle, it is important to choose one that is appropriate for the application. Consider the amperage rating of the circuit, the environment in which the receptacle will be installed, and any safety requirements. It is also important to use high-quality receptacles that are listed by a recognized testing laboratory, such as Underwriters Laboratories, or UL. UL-listed receptacles have been tested and certified to meet safety standards. When installing receptacles, follow all applicable electrical codes and regulations. The National Electrical Code, or NEC, provides detailed requirements for electrical wiring and equipment. Consult the NEC for specific requirements in your area. Properly installed receptacles are essential for the safe and reliable operation of electrical systems. By following these guidelines, you can ensure that your receptacles are installed correctly and will provide years of trouble-free service. Remember that electrical work can be dangerous, so always prioritize safety and consult a qualified electrician if you have any questions or concerns. In summary, the counterclockwise loop method is a fundamental technique for ensuring secure and reliable electrical connections when wiring receptacles. By understanding the principles behind this method and following the proper procedures, you can minimize the risk of loose connections, overheating, and electrical hazards. Always prioritize safety and consult with a qualified electrician if you are unsure about any aspect of electrical wiring. The NEC Article 110.3 B states that listed or labeled equipment shall be installed and used in accordance with any instructions included in the listing or labeling. The NEC Article 110.14 It covers termination requirements. It states that connection of conductors to terminal parts shall ensure a thoroughly good connection without damaging the conductors and shall be made by means of pressure connectors, including set screw type, pressure plates, and other approved means. The NEC Article 250 covers grounding and bonding. A proper ground provides a path for fault current to flow back to the source, which trips the circuit breaker and energizes the circuit. This protects against electrical shock. When working with electrical wiring, it is important to be aware of the potential hazards and to take precautions to protect yourself. Always turn off the power to the circuit before beginning any work. Use insulated tools to avoid accidental contact with live wires. Wear safety glasses to protect your eyes from debris. If you are not comfortable working with electrical wiring, consult a qualified electrician. Remember that electricity can be dangerous if not handled properly. The NEC is updated every 3 years, so it is important to stay current with the latest requirements. Consult the latest edition of the NEC for specific requirements in your area. Understanding basic electrical concepts such as voltage, current, and resistance is essential for safe and effective electrical work. Voltage is the electrical potential difference between 2 points. It is measured in volts. Current is the flow of electrical charge. It is measured in amps. Resistance is the opposition to the flow of current. It is measured in ohms. Ohm's law states that voltage is equal to current times resistance, or volts equals amps times ohms. This simple formula can be used to calculate voltage, current, or resistance in a circuit. For example, if a circuit has a voltage of 120 volts and a resistance of 10 ohms, the current flowing through the circuit is 12 amps. Understanding these basic concepts can help you troubleshoot electrical problems and ensure that your electrical systems are operating safely and efficiently. The NEC Article 310.15 covers ampacity, or the current carrying capacity of conductors. The ampacity of a conductor depends on several factors, including the size of the conductor, the type of insulation, and the ambient temperature. The NEC provides tables that list the ampacity of different types of conductors under various conditions. It is important to select conductors with an ampacity that is sufficient for the load they will be carrying. Overloading conductors can cause them to overheat, which can lead to insulation failure and fire hazards. The NEC Article 408 covers switchboards and panel boards. Switchboards and panel boards are used to distribute electrical power to various circuits in a building. They contain circuit breakers or fuses that protect the circuits from overcurrents. Switchboards are typically larger than panel boards and are used in commercial and industrial applications. Panel boards are typically smaller and are used in residential applications. It is important to select switchboards and panel boards that are appropriate for the size and type of electrical system. They should be installed in accordance with the NEC and should be properly maintained to ensure safe and reliable operation. The NEC Article 500 covers hazardous locations. Hazardous locations are areas where flammable gases, vapors, or dust may be present in sufficient quantities to cause a fire or explosion. These locations require special electrical equipment and wiring to prevent ignition of the flammable substances. Hazardous locations are classified into different classes and divisions based on the type of hazard and the frequency with which it is present. It is important to understand the classification of a hazardous location before installing any electrical equipment in that area. The NEC provides detailed requirements for electrical equipment and wiring in hazardous locations. These requirements are designed to minimize the risk of fire or explosion. The NEC Article 600 covers electric signs and outline lighting. Electric signs and outline lighting are used for advertising and decorative purposes. They require special electrical equipment and wiring to ensure safe and reliable operation. The NEC provides detailed requirements for electric signs and outline lighting, including requirements for grounding, overcurrent protection, and wiring methods. It is important to follow these requirements to prevent electrical shock and fire hazards. The NEC Article 700 covers emergency systems. Emergency systems are designed to provide electrical power to essential equipment during a power outage. These systems are typically used in hospitals, fire stations, and other critical facilities. Emergency systems require special electrical equipment and wiring to ensure reliable operation during an emergency. The NEC provides detailed requirements for emergency systems, including requirements for generators, transfer switches, and battery backup systems. It is important to design and install emergency systems in accordance with the NEC to ensure that they will function properly when needed. The NEC Article 800 covers communications systems. Communications systems include telephone, data, and cable television systems. These systems require special electrical equipment and wiring to prevent interference with other electrical systems and to protect against lightning strikes. The NEC provides detailed requirements for communications systems, including requirements for grounding, bonding, and surge protection. It is important to follow these requirements to ensure that communication systems operate reliably and safely. The proper selection and installation of electrical equipment and wiring are essential for the safety and reliability of electrical systems. By following the NEC and other applicable codes and standards, you can minimize the risk of electrical shock, fire, and other hazards. Always consult with a qualified electrician if you have any questions or concerns about electrical work.